Today we're going to look at how to solve radical equations. The steps are provided for you. First, you want to isolate the radical part of your equation. You'll raise each side to the power of the index, which we know the index is what's outside the radical sign. If nothing is written, we know it's a 2. We're going to solve for x, and then we have to check for extraneous solutions. Extraneous solutions, it's a solution that emerges from the process of solving that is mathematically correct but not a valid solution to the original problem. We'll definitely talk about that more as we go, but you do have to check at the end of each of these to make sure that the solutions that you get do work within the original problem that you had. So checking is not really an option anymore. Just make sure you got it right. Checking is to make sure you're not providing an answer that truly doesn't work. So for the first one, we have the square root of x plus 2 equals 5. We have to isolate the radical part of the equation. I'm going to take away 2 from both sides, leaving me with the square root of x plus 2 equals 3. At this point, I want to get rid of the square root, and the opposite of taking the square root is to square. So you're going to square both sides of your equation. This will leave me with the radicand, x plus 2 equals 9. You solve a simple one-step equation by subtracting 2 on both sides, x equals 7. So far, that appears to be our answer. We do have to go back and check it. The square root of 7 plus 2 plus 2, does that equal 5? Square root of 9 plus 2 is the same as 3 plus 2. That does equal 5, so 7 is a solution to our radical equation. In the second example, they already have it isolated for us. So I can take the square of both sides, leaving me with 2x plus 1 equals 9. Two-step equation now to solve for x. Pretty simple stuff. 2x equals 8. Divide by 2, x equals 4. Going back up to check it, the square root of 2 times 4 plus 1, does that equal 3? Square root of 8 plus 1, square root of 9, does equal 3. So 4 is a valid solution. Real quick, just to back up, I just want to show you how you could show this on your calculator. You would go into your y equals, and you'd put each side of the equation in separately. So you would do the square root of 2x plus 1, and then you would also put 3. If you hit graph, I think I'm way zoomed out. We may need to back out, but I think it'll still be okay because we can see the intersection there. Second trace or second calc. You hit 5 for intersect. It'll ask you for the first curve, and it's on the square root function. And then it'll go to the second curve, y equals 3. I want you to guess, so all I've done is press enter, 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 and it'll tell me the intersection is 4, 3. So there's our solution, x equals 4. So hopefully at this point you're saying, well, how come I don't have to write it as an ordered pair? But remember that the way that we have solved before where we've given ordered pairs are systems of equations, where you have the 2 variables. In this case, we have single variable equations. We just want to know what x is. If we had set these up as 2 individual equations, like y equals the square root of x plus 2 equals, and then y equals 5, then we would be looking for that solution as an ordered pair. All right, for number 3, I'm going to take and square both sides. The square root of x squared plus 9 becomes just x squared plus 9 when we square it. Negative 5 squared becomes 25. When I start to solve it, I get x squared equals 16. X equals both positive and negative 4. So I'm going to go check those. If x equals 4, the square root of 16 plus 9 equals negative 5. The square root of 25 equals negative 5. Not a true solution. X equals negative 4. We're going to see something very similar happen here, because when you square your negative, you're going to get that same 16 plus 9, 25, square root of 25 does not equal negative 5. So this one actually has absolutely no solution. So there's your extraneous solutions happening. Mathematically, everything we did was accurate, but what happens is whenever you square things, you tend to lose information. You just have to make sure that those solutions that you do get do work within the context of the original problem. And extraneous solutions pop up in several situations. What we're focusing on this year, it'll really only pop up when we're dealing with radical equations. Moving to number 4. So this is where it starts to get slightly tougher, because we've really been just dealing with 1- and 2-step equations. Now, if I square this side and I square this side, I'm left with what's under the radicand, or radical, so I have x plus 16 is left. And over here, I have a binomial squared, so you're going to have to use your foiling option. X squared would be x times x, then it would be 4x plus 4x, or 8x, plus 16. If you have to come to the side of your paper and foil it out, definitely do that. But remember, this is one of those special cases where you can just double your term. You have to move everything to one side of the equation, set it equal to 0, so that we can factor it potentially. So I'm going to move everything over here so I can keep my x squared positive, although I'll write it to the left. So I have x squared, I'm going to minus 1 to make that 7x, and then minus 16, which leaves me with 0. This is a pretty simple factoring job, because we can just pull the x out, since that's the GCF of these two terms. So at this point, x could equal 0, or x could equal negative 7. So we do need to go back and check both of those solutions. So if we're checking for x equals 0, the square root of 0 plus 16 is 16, equals 0 plus 4. Square root of 16 is 4, 4 equals 4. So x equals 0 is a solution. If we check for x equals negative 7, negative 7 plus 16 is 9. Does 9 equal negative 7 plus 4? 3 does not equal negative 3. So this is not a valid solution. That is an extraneous solution. It came from doing things mathematically correct, but again, when you square things, you lose information. Number 5. Again, you have to get your radical alone, so I need to subtract 2 from both sides. And then from this point, I will square it. So I have x plus 4 equals x squared minus 4x plus 4. I'm going to move everything to one side. X squared. Take away x from both sides, leaving me with minus 5x. Take away 4 from both sides, leaving me with no constant. And everything equals 0. Very similar to the last one. You're going to pull the x out from both terms. That leaves me with solutions that x could be 0 or x could be 5. So let's check it. If x equals 0, the square root of 0 plus 4 is 4 plus 2 equals 0. Square root of 4 is 2. 2 plus 2 does not equal 0. So 0 is not a solution. It's an extraneous solution. We check for x equals 5. Square root of 5 plus 4 is the square root of 9 plus 2. Does that equal 5? Square root of 9 is 3. 3 plus 2 equals 5 is true. Our valid solution is x equals 5. And then one more, number 6. We have everything already to one side. in terms of the radical. So I'm going to square it, leaving me with x plus 3 equals 4x squared. I'm going to move everything over here to keep my 4 positive, so I have 4x squared minus x minus 3 equals 0. At this point, you may have to go do some work with factoring, because of 4 not being a prime number, we may have it be 2x and 2x, we might have it be 4x and 1. Take a minute and see if you can factor that on your own, just for some good old practice. I already completed it, so I have 4x times x, and a minus 1, that'll give me negative 4x. Then I'm going to add 3, so there's my negative 1. 3 times negative 1 is negative 3. So x could equal negative 3/4, or x could equal 1. Sometimes they will both work, so there's not always going to have to be an extraneous answer whenever two solutions pop up. So let's check the first one, x equals negative 3/4. Underneath the radical, whoops, I broke through the bed, sorry. Underneath the radical, I have negative 3/4. If I add it to 3, that gives me 2.25, or 2 1/4. Does that equal 2 times negative 3/4? Without even worrying about getting my calculator, you could hopefully see that that's never going to be true. Taking the square root of a number isn't going to give you a negative answer. So I know negative 3/4 isn't going to work. Let's check for x equals 1. The square root of 1 plus 3 is 4. Does 4 equal 2 times 1? Oh, I'm sorry, 4 times 1. Nope. Yeah, 2 times 1. 2x. Square root of 4 is 2. 2 times 1 is 2. X equals 1 is the solution. Just to make sure everybody feels so confident using the calculator, because you will have access to a calculator for this test, you do have to show me algebraically how you got your answers, and I want to be able to see the extraneous solution. So the calculator isn't going to tell you extraneous. You have to be able to solve them algebraically. But then the calculator is an awesome opportunity to check your answer. So I have x plus 3, and here I have 2x. If I graph that, I'm going to go ahead and do zoom standard. So it's a little bit more zoomed in than the last question. You're going to use second trace and option number 5, their intersection. And pick enter for the first curve, enter for the second curve, guess, and they'll tell you the intersection is x equals 1. As part of your homework, go ahead and finish number 7 and number 8. Those are word problems involving the square root function.